Another type of force problem that you might encounter is one that involves tension. Picture a box hanging from the ceiling by a rope. We know that there will be a force acting downwards on the box due to the force of gravity. But if the box is stationary, we know that there also can't be a net force. So there must be another force counteracting this one. Anytime an object is connected to a rope, a string, or a wire, there will be a pull force exerted on the object. In this case, a tension force is present in the rope acting away from the box up towards the ceiling. And this force is equal to the force due to gravity, resulting in a net force of 0. These problems can get significantly more complicated. In the following problem, a box is suspended from the ceiling by two ropes. One rope makes a 30-degree angle with the box, and the other makes a 60-degree angle. Given the mass of the box, you're asked to find the tension force in each rope. We know that the force due to gravity will exert a downward force on the box. Multiplying the box's mass by the acceleration due to gravity, we find that the force due to gravity is negative 49.05 newtons. Note that this value is negative since it acts in the negative y direction. We know that the tensions will act in the direction pointing away from the box, and we can label these T1 and T2. We'll need to break these two tensions into their x and y components. Because the box is stationary in both the x and y direction, we know that the sum of forces in each direction will need to equal 0. Now we can see that the only two forces in the x direction are T1x and T2x. We can then write that T1x plus T2x is equal to 0. However, we'll need to write these in terms of T1 and T2 in order to solve for their values later on. Using trig, we can say that negative T1 cosine of 30 plus T2 cosine of 60 equals 0. We put a negative in front of T1 because T1x is acting in the negative x direction. Alternatively, we could have written it as T1 times the cosine of 150. We see that there are three forces acting in the y direction. We have T1y, T2y, and the force due to gravity. Because the box is stationary in the y direction, we know that these will need to add up to 0. We can then write T1y plus T2y plus the force due to gravity is equal to 0. Using trig, we can then say that T1 times the sine of 30 plus T2 times the sine of 60 plus the force due to gravity is equal to 0. This now just becomes an algebraic problem where there are two unknowns and two equations. If we solve the first equation in terms of T2, we're able to find that T1 is equal to T2 over radical 3. We can then just plug this value into the second equation for T1. Solving the second equation for T2, we eventually find that T2 is equal to negative radical 3 over 2 times the force of gravity. Plugging in the force due to gravity, we find that T2 is equal to 42.48 newtons. Plugging the value we found for T2 into the first equation, we're able to find that T1 is equal to 24.53 newtons. We can now use these values to solve for the individual components. This is also a way to check that our answers are correct. We know that T1x is equal to negative T1 times the cosine of 30. Plugging in the value that we found for T1, we find that T1x is equal to negative 21.24 newtons. This negative value makes sense since we see that T1x acts in the negative x direction. We know that T2x is equal to T2 times the cosine of 60. Plugging in the value that we found for T2, we find that T2x is equal to 21.24 newtons. We can also see that this value makes sense since it cancels out T1x, leading to a net force of 0 in the x direction. T1y is equal to T1 times the sine of 30. Plugging in the value that we found for T1, we see that T1y is equal to 12.27 newtons. T2y is equal to T2 times the sine of 60. Plugging in the value we found for T2, we find that T2y is equal to 36.79 newtons. We find that the values for T1y and T2y add up to 49.06 newtons. Note that the value that we found for the force due to gravity is negative 49.05 newtons. You'll often have some small rounding errors like you see in this case, but we can see that these two tension components basically cancel out the force due to gravity. After finding the two tension values in a problem like this, it's always good to find the individual component values. If you find that the forces add up to 0 in both the x and the y directions, you can pretty much be sure that you got the answer correct. I hope that this video was helpful, and be sure to comment below if anything was unclear. If you did find this helpful, please give this video a like and consider subscribing to the channel for more fast physics help videos. Thanks for watching.